estimation, the area is 0.1 million square kilometer, and the volume is 0.1 million square kilometer cube. And it is a short period of magmatic activity, geologically short period, that is 1 to 5 million. It may include single pulse or multiple pulses. If we are taking into account the multiple pulses, the magmatic activity takes a time of 50 million years. With respect to the composition of the magma that is generated in this setting, that is mostly mafic and ultramafic composition. In addition to that, in the large igneous province, we also consider the silicic magmatism. But this is a different class of large igneous province, which is known as silicic large igneous province. As I was telling, it is mostly intraplate magmatic activity because it is generated within plates, and also it has geochemical affinity towards intraplate setting. If we classify the LIP, it may be associated in the continental plate, it may be associated in the oceanic plate. If we are considering continental plate, there are different components of the large igneous province. And one of the most important component, that is continental flood basalt. And you all know the most important continental flood basalt province of the Indian shelf, that is your Deccan Plateau. Or in geological sense, we call it Deccan large igneous province. In addition to that, the other components of large igneous provinces are plumbing system, that may include regional mafic dikes, that may include sill provinces, that may also include mafic, ultramafic layered complexes. In addition to that, the other components of continental LIP are slip, silicic large igneous province. In addition to that, we also considered several other magmatic activity, that is your carbonatites, kimberlites, lamprophires, and lamproids. We must have heard about one of the most important carbonatite deposit of the Indian Sea, that is located at the Gujarat provinces. In addition to that, in the oceanic plateau, which have less idea about how it is formed, what is the extent of this oceanic plateau, oceanic large igneous province, but we also classify the oceanic LIPs. They are oceanic plateau and oceanic basin flood basalt. I have summarized one of the several well-known LIPs of the world. One of the important LIP I was talking about, the Deccan large igneous province, which has an age of 65 to 66 million years. Siberian trough, which has an age of 25 and 250 million years. Columbia River Plateau in USA, that is has an age of 16 million years, and Itandeka LIP, that is at Namibia. But you can see these LIPs are mostly recent LIP. In these LIP, as you can see in the diagram, the continental flood basalts are well preserved. But if we go back to the time to the Precambrian, these continental flood basalt, what we are observing in the Deccan Plateau, they are completely eroded. And how we'll identify whether this is a part of LIP or not? By identifying the location of large-scale mafic dikes. These large-scale mafic dikes are well exposed throughout the different patterns of the Indian sea. If we discuss about how these large igneous provinces are generally originated, although there are several theories are there to explain the genesis of these large amount of mafic magma, but one of the most important and accepted theory is the mantle plume hypothesis. Mantle plume that generally comes from the core mantle boundary, you can see, and it comes to the asthenospheric mantle, and it then interacts with the lithospheric mantle. As I was discussing about the different component of large igneous province, you can see how the different components of large igneous province are forming in a mantle plume setting. These are radiating diaphragms, these are flood basalt provinces, these are circumferential dike, these are magmatic underplate, these are mafic and ultramafic cells. These are the different components of large igneous province that is basically formed due to the interaction of the mantle plume with the lithospheric mantle or asthenospheric mantle. Why the large igneous province research is important? Because we are dealing with the several important hypotheses that we are going to resolve by the study of large igneous province. one of the important hypotheses, that is the evolution of Earth's mantle. How the Earth's mantle, whether it is lithosphere or asthenosphere, has changed with time. As I was saying, the magma comes from lithosphere and asthenospheric mantle. If we study different large igneous province, we will collect large igneous from Archean time, we will collect large igneous province from Proterozoic time, and from recent time. And if we will study its geochemical evolution, and we can find out how the Earth's mantle has changed with time. Second thing is metallurgy. As I was saying, large igneous province has generated huge amount of mafic and ultramafic magma. Obviously, if you are dealing with mafic and ultramafic magma, they must associate some amount of metallurgy, whether it is nickel, whether it is cobalt, whether it is different PG, whether it is copper. So, defining the association of different metallurgy with large igneous province is important. In the global platform, some metallurgy is associated with LIP and some LIPs are completely barren. So it is necessary to define the geochemical constraint on the association of metallurgy with LIP. Third point is the environmental changes that it is going to affect when it is erupting large amount of magma. As I was saying, in the Deccan LIP, it is generated a magma at 65 million. And we all know the 65 million year magmatic activity is supposed to be the extinction of dinosaurs. So when it is erupting large amount of magma, along with the magma, several gaseous forms like carbon dioxide and sulfur dioxide is coming into the atmosphere. So it is going to affect our environmental change and also catastrophe like dinosaur extinction. And the fourth important point, the significance of large igneous province, that is paleocontinental reconstruction. During the generation of large igneous province, large amount of mafic magma is generated. What the continental location we are observing now, during Archean and Proterozoic time, the position of the continents were not like that. So by observing, by studying the synchronous magmatic activity or contemporaneous magmatic activity in different provinces worldwide, we can define which cratons or which continent were the neighbors during the geological time. So paleocontinental reconstruction is one of the important parameters that we are going to define by studying LI. In addition to these four important research frontiers, I am basically working on other four parameters that I have mentioned here. We are dealing with the Archean LIPs. In the phenologic LIP or recent LIP, the flood basalts are present. But in the Archean LIP, we are mostly focusing the identification of large igneous province through study of mafic dikes. So the mapping of the large igneous province is one of the important component of large igneous province study. So we are doing the mapping of large igneous province by several fieldwork through Google Earth image study and geochronological data set. In addition to that, we are also evaluating the economic potential of different large igneous provinces of the Indian. In addition to that, we are also doing geochemical study by studying whole rock geochemical analysis, isotope geochemical analysis, by which we can evaluate the nature of mantle source from which these magmas are coming. We are also studying about the emplacement systematics of these large igneous provinces. In terms of emplacement systematic, we are studying about the mechanism of emplacement, whether the magma is coming in a vertical setting or the magma is coming in a horizontal setting. That can be achieved by the study of anisotropic magnetic susceptibility and fracture system data. In the next discussions, I am going to discuss these four important frontiers on which we are working. As I was saying about the mapping of large igneous province, Indian silts hold several generations of spectacular mafic diagrams which are exposed in the different cratons of the Indian silt. Whether you take Dharwar craton, whether you take Singhbum craton, whether you take Bundelkhand, whether you take Arabali craton, all these cratons hold spectacular cross-cutting, large and huge scale mafic diagrams. Based on the mapping of mafic diagrams, we have identified 3 Archean and 12 Proterozoic LIP events in the Indian silt. And I will show the example of Dharwar and Singhbum pattern, how this mapping has been done. In the Dharwar pattern, this is the map of, I will precisely say that is the diagram map of the Dharwar and Singhbum pattern. You can see several colors are marked. That is for the different generations of mapping diagrams. As I was saying, we are basically dealing with the Archean or Precambrian mapping diagrams. In the Dharwar pattern, from 2.37 G, 2.37 giganum to 1.89 or 1.73 giganum, 9 generations of mafic magmatism has happened. And these 9 generations of mafic magmatism has been marked in this map with a different color. Before that, this marking or this classification of mafic diagrams into different events has not been done. By using Google Earth image, I will show how these mafic diagrams are identified by using Google Earth images, and also conducting several field work. We have prepared this map from for this is for the Dharwar pattern and this is for the Singhbum pattern. These are the diagrams that we generally observe how it looks like in the field. You can see bouldery outcrop. This is the country rock, that is granite, and these black color outlines, these are mafic diagrams. You can see how huge and how large it is. In the Google Earth images, in the Dharwar pattern and Singhbum pattern, the country rock is granite. That is, by tonal difference, it can be easily distinguished from the country rock. The country rock is granite, and these linear bodies, generally it is linear bodies, and these cross-cutting bodies, these are mafic diagrams. And as it is mafic and ultramafic its composition, obviously their color will be darker in comparison to the granite. Therefore, by using Google Earth image, we can identify how what generations of diagrams are in place. This is all about the mapping of diagrams that we are working. And the second component is the economic potential of large igneous projects. As as I was saying, huge amount of mafic magma has been generated during the Earth's different time. So it needs to constant its geochemical characterization, whether it is geochemically potential to hold different metals or other economic deposits. So it can be done by using several proxies. The proxies that we are using, that is its geochemical constraint. By using whole rock, trace element and rare earth element studies, we can characterize whether it has potential or it is completely barren. In terms of economic potential, the crustal contamination is important parameter. When a magma is coming from mantle, whether it is lithosphere or asthenosphere, it must interact with the crust. And we need to establish whether there is significant interaction or whether it is less interact with the crust. By using several trace elements like the proxies from trace element from crust and the proxies for trace element for mantle. That is thorium, one of the important element that is considered as crustal element, and the niobium is one of the mantle element. By taking the ratio of thorium and niobium, we can establish whether the magma that has been generated in LIP contain significant amount of crust or not. By evaluating these parameters, we have suggested the Indian LIPs has potential for future study in respect to the economic potential. So I have marked several large igneous provinces, but with respect to general message, I want to say the Indian LIPs has economic potential for future exploration. And third important parameter that we are working about the nature of mantle source. In terms of research frontier, it is important because in the igneous petrology, all research lies what is the nature of source. Several people are working on that domain, igneous petrology and geochemistry. People are using different proxies. But at the end of the research, we need to define what is the composition, how much percentage of melting has happened, what is the source rock. These are the different parameters. By using geochemical proxies, we have defined the nature of mantle source for the mafic diagrams of the Dharwar pattern. For the first time, we have reported that apart from peridotite source, that we generally believe mantle is of peridotite composition, that is ultramafic in nature, olivine and pyroxene in composition. But in the Dharwar pattern, we have defined a specific type of mantle composition, which is peridotite plus pyroxenite in composition. Similarly, as I was saying, another important frontier of large igneous province to define the cratonic neighbor. We know the neighbor of our country during the recent time. But in the ancient time, in the Archean time, in the Proterozoic time, who are the cratonic neighbor of Indian sea? So for that purpose, we define the barcode. We all know about the barcode. But every craton has its own barcode. Barcode is nothing, it defines the magmatic event that has happened in the geological past. That can be prepared by using available geochronological data. We date the rock and we define at which time this rock has been emplaced. So you can see by comparing the LIP barcode of different cratons, you can see craton A and D. These are T1, T2, T3, T4. These are different magmatic events. And A and D has similarity in terms of magmatic event. Similarly, C and D has some similarity in terms of their magmatic event. By comparing these geochronologically dated magmatic events, we can say these are cratonic neighbors. By using this principle, we have defined the cratonic neighbor of our different cratons, that is Dharwar, Bastar, and Singhbum craton. You can see several matching events are there in terms of the magmatic activity. As I was saying, the magmatic events of LIP scale can help to define the paleocontinental reconstruction. During 90 million years, the Indian shield has been separated from the Madagascar by Marian flow. During 117 million years, the Kerguelen plume has played significant role in the separation of the India on the eastern side. Similarly, the Deccan Plateau that is formed due to the reunion mantle plume that you can see the Deccan large igneous province that is due to the reunion plume. That is the present location of different plume centers in the Arabian or Indian Ocean. So I was discussing about the different research frontiers of large igneous province. So key takeaways from this LIP research. LIP has significant potential with respect to metallogeny. So country's economy is also dependent on the LIP research. So at the end, I can say LIP is always important, whether it is human body or in the geological history. Thank you so much.
Oceanic plate and continental plates are completely different, these two plates. But what will happen in the movement of continents? These two move independently or how?
Every plate has its own independent motion.
Right, but in the plate tectonics, what we study, plate tectonics are huge land masses, including the sea part, ocean part also. Along with that, it moves. But you said these two are two independent.
Because I am saying independent with respect to their composition. If you are talking about continental fluid,
both are moving.
Both are moving.
And both are actually interacting.
Interacting with each other.
Okay.
Both are moving, both are interacting with each other.
Okay, thank you.
Yeah, isotopic age support.
Sir, for all these 9 generations of mafic diaphragms, isotopic studies are not available.
Yes.
For some generations of diaphragms, isotopic studies are available.
Yes, but then because the directions based on that, always it may not be very correct, I think.
Yeah, I completely agree. The preliminary studies is done through the whole rock and geochemical analysis. For most confirmed association, we need to study their isotopic characteristics. Whether it can be radiogenic isotope, stable isotope, there are different isotopic systematic factors. So we